Hello friends, I'm a cloud solutions architect at Microsoft and my aim is to empower every single person to be better at technical interviews. Keeping with that goal in mind, today we are going to do a very interesting LeetCode problem, so let's get started with that. So today we are going to find the Celebrity LeetCode problem, and if we see some of the popular companies, the problem has been asked at companies like Amazon, LinkedIn, Pinterest, Microsoft, Facebook, Apple, Snapchat, Google, Uber and Goldman Sachs. So basically all the popular companies have asked this question. So I'm going to pay my utmost attention. I hope you also enjoy the video. This has to be one of the most interesting problems I have been able to find so far. If you look at this, a LeetCode categorized this as a medium problem. If you try to understand the problem statement and try to think about it, you will feel like this is actually a hard problem. And once you put like some more thought into it, you are actually going to feel that this is actually an easy problem. So in my opinion, this is actually an all-in-one problem. Let's understand the problem statement to go further deep. It says that suppose we are at a party with n people and the names of these people are the numbers. So basically numbers from 0 to n minus 1. So say for an example, we are in a party with 4 people. Basically the people are going to be 0, 1, 2 and 3. So these are going to be the 4 people. Now we are told that in this party there may exist, so this is an important part, that there may exist, which means there might be a celebrity or there might not be a celebrity. Okay, now we are first of all given that what the definition of a celebrity is. The definition of a celebrity is that that every single person in that party knows who the celebrity is. And the second condition is that celebrity does not know any single person in that party, which is how typical celebrities are. So now given these two definitions, first of all, we are told that we need to check that whether there exists a celebrity or not. And if there exists a celebrity, basically we need to find that who that celebrity is. The question is how we are going to find who that celebrity is. Well, definitely over here the relationship is based on either people knowing who the celebrity is or the fact that celebrity knows no one, that everyone knows celebrity and celebrity knows no one, right? Now at our advantage we are given a methodology where we can check between any two entities whether they know each other or not. We have a method boolean knows A to B, which defines that whether A knows B or not. If A knows B, if this gives answer true, which means A knows B. If this gives answer false, which means A does not know B. And why we are using that? Because the only relationship we have to identify whether a person is a celebrity or not is by the amount of people know them or the amount of people they know. And in this case we either need to find the celebrity or we need to return -1 if no celebrity exists. So I know this is a little bit complicated to understand, but let's try to see some examples for this problem. Okay, so in the problem we are actually going to have an input that looks like this, where in this input we are given a list that contains some values that defines the relationship between any two values, that whether they know each other or not. Now the thing is, this input is kind of messy, so I'm not actually going to show you examples based on this exact input. I'm actually going to show you in the base of something that is easier to visualize. So this is the same input I took from here, but I have actually converted it into a 2D matrix. And basically as an input we are given a graph, or we are basically given an adjacency matrix. Okay, so for this adjacency matrix, based on this adjacency matrix we are given two entities. We are given a person and we are given whether that person knows each other or not. This diagonal line is always going to be 1 because that defines that whether person 0 knows person 0 or not, whether person 1 knows person 1 or not, things like that. And that is always going to be 1. So we can simply ignore this one. This serves no purpose. The important thing in this case is this defines that whether person 0 knows person 1 or not. So this answer is 1, which means that person 0 knows person 1. Let's try to find who the celebrity is in this problem, right? So in this case we are given basically 3 person. So we can actually create a graph that looks like this of 3 person, and we are going to name them as 0, 1 and 2, right? Now the thing is, relationship between them is actually going to be the relationship defined by an edge, where a edge would represent that whether one entity knows the other entity or not, or one node knows the other node or not. And this is going to be a directed edge. Why? Because it could be possible that 0 knows 1 but 1 does not know 0. So we cannot just simply have an undirected edge, we must have a directed edge in this case. So let's try to do that as well. So if we draw it from this graph, okay, 0 0, this does not matter, these three values, so we'll just ignore them. Let's just start 0 with 1. So 0 knows 1, right? So which means 0 knows 1. Yeah, we mark it. Now does 0 know 2? No, 0 does not know 2, so there is not going to be any edge. Now whether 1 knows 0? No, 1 does not know 0, and 1 also does not know 2, so 1 does not know anyone. Now in this case, whether 2 knows 0? Yeah, so 2 knows 0, that is good. And whether 2 knows 1? Yeah, 2 also knows 1, so that is also good. And 2 knows 2? Yeah, that is true, so we can ignore that. In this case, if we see the two definitions of a celebrity, that everyone knows who the celebrity is and celebrity knows no one at the party. So definitely in this case, we can say that, hey, if we check out the input for this value number 1, it knows itself. But the thing is, that is not the point. The point is whether it knows anyone else at the party or not. So 1 does not know anyone at the party, that is true. And also 0 knows 1 and 2 also knows 1, which means every single one who is every person other than 1 knows who the 1 is, and 1 does not know anyone, which means 1 perfectly fits on our category of celebrity, and in this case 1 is going to be celebrity. So we will simply return 1 as the answer, and this is what we need to return. Okay, let's see one more example. In this case, again 0 1 and 2. Let's draw 3 lines. Now ignore these 3 cases, and 0 knows 1? No. 0 knows 2? Yes. So 0 knows 2. Okay, does 1 know 2? Yeah, 1 also knows 2, that's good. Whether 2? Okay, 2 knows 0. So in this case 2 knows 0, and 2 knows 1? No. So in this case, can we find any celebrity? Actually we cannot find any celebrity. Why? Because in this case, okay, 0 and 1, both of them know 2, so that is good. 2 qualifies for one of the property of being a celebrity. The thing is, second property of being a celebrity is that it has to know no one at the party. But in this case, 2 actually knows who the 0 is. So because 2 know one person, 2 does not qualify for the second entity of our answer. So in this case, we cannot find any celebrity. So because there is no celebrity present, we are simply going to return -1 as the answer. And this is what we need to return. Okay, so first approach is a brute force approach. In the brute force approach, what we are going to do is we are simply going to check that whether all the person that are given, can any single one of them is a celebrity. So for one by one, we are going to check for every single person whether they are celebrity or not. So in this case, what we are going to do is first we will consider person 0. Okay, so for the person 0, we will try to see whether 0 is a celebrity or not. How can 0 be a celebrity if everyone else knows who the 0 is and 0 knows no one? So in this case, we can see that 0 knows someone, so 0 is not a celebrity. Now we will have to check whether 1 is a celebrity or not. So in this case, okay, 1 still knows someone, so 1 cannot be a celebrity. But and in this case, we'll try to see whether 2 is a celebrity or not. So 2 knows no one, and let's see that if everyone knows 2 or not. So this one knows 2, but this one does not know 2. So 2 is also not a celebrity. So in this case, we will return a -1. And this logic leads us to the correct answer. Maybe if you make some modifications or tweaks, it can be an acceptable solution as well. The thing is, this is still not the most optimal way to solve this problem. So basically, we would end up solving this problem in big O of n square time. So which is not too bad for some of the problem, but it is really bad for this problem because this can be done very efficiently with other methods. So let's try to see what that other methods could be. So in this scenario, if we see, okay, 0 knows 1 and 2. So 0 knows 1 and 2, right? Same way, 1 does not know anyone, and 2 knows 1 and 1 and 0. So 2 knows 0 and 2 knows 1. So basically answer is going to be 1. That is a given fact. The thing is, what is one smart trick we can use? The smart trick is the knows function. The knows function that we are given in the input, that is there for a reason. And what knows function does is that if we provide any two values, say for example, if we provide the values of 0 and 1, it is quickly going to tell us that whether 0 knows 1 or not. So in this case, okay, 0 knows 1, that is a true fact. Now the thing is, if we know for sure that 0 knows 1, what is one thing we can say for guarantee? we can say for guarantee or for certainty that 0 cannot be a celebrity. Why we can say that? Because remember the definition of a celebrity. The definition of a celebrity is that everyone knows the celebrity and celebrity knows no one. Which means in this case, if we try to find or if we try to see this knows function between 0 and 1 and the answer is true. If the answer is true, definitely we can say that 0 cannot be a celebrity, which means we are eliminating 0. Now, what could be the second possibility? Second possibility could be, say for an example, if we try to use the knows function for values 1 and 2. If we try to use the function 1 and 2 knows, and the answer is going to be false. Why the answer is going to be false? Because 1 does not know 2. If 1 does not know 2, what is also one more thing we can say for certainty? Well, we can say for certainty that in this case 2 cannot be celebrity. Why 2 cannot be celebrity? Because we found at least one element that does not know 2. And in order for 2 to be celebrity, celebrity has to be known by everybody else in the party. So because we find one entry over here who does not know 2, we can say for sure that 2 is not a celebrity. Which means depending on the result of this knows function, if the value is true, we can eliminate one value, that is the first value in the knows function. If the value is false, we can eliminate the second value inside this given input, which means with every single knows call, we are getting rid of one element. So in this case, after just making 2 calls, we were able to get rid of 0 and 2, which means if there exists a celebrity, it has to be 1. So now all we need to do is that since this is the last item or last value pending, do we need to check that whether everyone knows 1 or not? No. Why? Because since we know for sure that these two are not the celebrities, right? So all we will have to worry about is that whether one knows no one. If one knows no one, which means one has to be the celebrity. If one knows at least one person, which means there are no celebrities inside this input, and we can simply return -1. And this is the whole logic behind this problem. Let me try to explain very quickly with a big example. So now we have a bunch of different values over here. Basically, we are simply going to use the knows function and we are going to go through every single value and try to see whether it knows the next value or not. So first we'll try to see that whether the 0 knows 1 or not. So, and we can ignore all of these values because diagonals doesn't matter. We do not care if they know their own self or not. So in this case, okay, 0 to 1, 0 does not know 1, which means we can say for sure that 1 cannot be celebrity. If 1 cannot be celebrity, we can simply skip over to the second value. Now in this case, we will check that whether 0 knows 2. So in this case, 0 to 2, 0 knows 2. So because 0 knows 2, we can say for sure that 0 cannot be a celebrity. So we ignore this. Now we are at this value number 2. So we'll try to see whether 2 knows 3 or not. So 2 to 3, if we check, okay, 2 knows 3. So if 2 knows 3, definitely 2 cannot be a celebrity. So we will ignore that. Now we are at this value number 3. So we'll check for 3 to 4. So 3 to 4, if we check, yeah, 3 knows 4. So in this case, 3 cannot be a celebrity because 3 knows 4 because of this value. Now we are at this 4 position number 4, 4 to 5. So if we see 4 to 5, so 4 to 5, this value is actually 0, which means 4 does not know 5. So because 4 does not know 5, 5 cannot be a celebrity. So in this case, we have actually got rid of all of these elements and only 4th value is pending. So now we know that if there exists a celebrity, it has to be 4. Otherwise, there are no celebrities. So now we are simply going to check that whether 4 knows anyone or not. And for that, we simply have to do one check at this 4th row to see whether apart from 4 by itself, does it know anyone else? And it knows no one. So definitely 4 is the only candidate left and 4 knows no one. So in this case, 4 is definitely our celebrity, and this we can simply return as the answer. And this is the whole logic behind our answer. Say for an example, in this case, by chance, if 4 knew this value number 1, if this was answer 1, then simply we can say that, okay, 4 is also not a celebrity, and we can simply return -1 in this case. But thing is, because this value is actually 0, so in this case, answer is actually going to be 4, and we are solving this problem most efficiently. If we see time complexity in this case, the time complexity is actually going to be big O of n. And if we see space complexity, well, apart from using couple of variables, we are not using any additional space, so space is actually going to be constant. First, I identify few things. So I created a new global integer to use the number of people, and I have assigned it to the value of n. And basically in the problem, we need to resolve this find celebrity problem. And also for this problem, I have created is celebrity a helper method. So that is going to define that whether any single candidate that we have been able to identify from this find celebrity method, if that is a celebrity or not. And now first let's start implementing this find celebrity method, and then we will implement our is celebrity method. So first of all, we are going to initialize a variable called celebrity candidate. Now we are going to run our for loop, and for every single value we are going to check, or we are going to call our nose function. And for the nose function, we are basically providing the value of the celebrity candidate and the value of current I. Now, depending on the answer we get back, we are going to update the value to the I. So what this is going to do is, this is simply going to eliminate every single value for us except one last remaining candidate, and that we are going to consider as the celebrity candidate. And once we get out of the loop, all we will have to do is we will have to call our is celebrity method. If this value is actually true, if this value is a celebrity, we are going to return this. And if that is not the case, we can simply return -1. Now in this method, we will first of all run a for loop. Inside the for loop, first we will have to check that if the given value of I is equal to j, which means we have found a diagonal value. So in this case, we simply ignore that. And if that is not the case, we are going to check that whether j satisfy all the properties of being a celebrity or not. If any of these is true, we can simply return false. And if that is not the case, and if we get out of the loop, we can simply return true. And I think this has to be the whole logic behind this input. So let's try to run this code. Seems like our solution is working as expected. Let's submit this code. And our code runs pretty fast compared to a lot of other solutions, and it is also really efficient in terms of time complexity. So this was a great problem to solve and to understand a lot of different concepts. I would be posting this solution in the comments, so you can check it out from there. Thank you.